Hi guys. Okay, so now let's look at our problems from the book. This is chapter 2, Atoms, Molecules and Ions in the Open Stax chemistry book, the second edition. Okay, so we are looking at the learning check problems. That is 2.2. So what is given to us? Here we are given two samples, sample X and Y. Both of them are clear, both of them are colorless. However, the difference is in the odor. One of them has a very specific type of odor, but the second sample is smelling a little bit different. So the odor is different, and odor is like a defining, it's defining like the identity of this particular X and Y compound. So we just want to make sure that both of them are indeed different and not the same. So the question is asking, tell us whether this is, the question is asking, are the data. So you're given a data in which you are given, for sample X, there is 14.13 grams of carbon and 2.96 grams of hydrogen. These are present, okay? And you are given in sample Y 19.91 grams of carbon and 3.34 grams of hydrogen. So the question is, are these data an example of law of definite proportions, or is it the law of multiple proportions, or neither? So which of these laws is applying? So in other words, are these the same compound or are they the different compound? So this is what we need to find out. Just this, the odor could be due to any other thing. It doesn't matter. So are these the same or two different samples, like two different compounds? Or is it the same compound? Okay, so what do we do here? We are going to look at, first of all, the ratio of the mass ratio of carbon and hydrogen. So let's look at the mass ratio of carbon to hydrogen. Okay, and there is a little misprint in this book. It's actually hydrogen and not oxygen, because the question relates to hydrogen. So the answer is it looks like a typing error. So anyway, so here we have the ratio in X. What is that? We are given 14.13 grams of carbon, okay? And we are given 2.96 grams of hydrogen, okay? This is in X. The compound Y has 19.91 grams of carbon, and we have 3.34 grams of hydrogen, okay? Now, in the ratio of carbon X, and so ratio, if there was 1 gram of hydrogen in this, when you solve this, so for every 1 gram of hydrogen, we see that there is, in the case of X, we have 4.77 grams of carbon present. And in this one, we have 5.96 grams of carbon. So naturally, one difference is the carbon. For every 1 gram of hydrogen, the amount of carbon is changing. And so when you combine these two, you are going to see that when you combine these two guys, that is 4.77 and 5.96, you get 0. So here we have 4.77 grams of carbon per 1 gram of hydrogen, over, if you have 5.96 grams of carbon over per 1 gram of hydrogen, you get 0.800. And this is equal to 4/5. So this is obviously very different. So this looks like a very small change. However, this whole number supports the law of multiple proportions. That means these are, yes, definite, of course, but multiple. So it's more than one type of compound. So multiple proportion means that these are two different compounds or two different molecules. So compounds is like more macroscopic, Molecules is more microscopic. So remember, molecules are a part of the compounds. Okay, so that's 2.2. Let's look at the next problem now. Okay, so we see here in problem, the learning check problem on page 81, 2.3, we see we are given platinum, and we are given the mass of platinum. The symbol for platinum is Pt. The mass given is 95, and it is the atomic mass units, right? And the number of electrons are 74. So the question is, find how many protons are there, how many neutrons are there, and what is the charge. So how are we going to do this? Okay, so here there's certain things that you would need is the atomic number and the mass number. Okay, so only the mass number is given, and in order to find the number of protons, you need the atomic number. So where are you going to get the atomic number? Look for the atomic number in the periodic table. Look for atomic number, because atomic number is very unique to the elements. If there are 78 protons, only then it will become platinum. If it is 79 protons, it's a different. If it is 77 protons, totally different. So look for the atomic number in periodic table, and that atomic number is the number of protons. So the number of protons is equal to 78, right? And we have the number of electrons that are already given is 74. So we clearly see that there are less number of protons, less number of electrons. And what is that? So number of protons minus the number of electrons, and that give you, that is 78 minus 74, and that is a positive number, that is +4. So the charge then is equal to +4 on platinum, and it looks like this. You can either write it like this, +4, or you can write it 4+, okay, or you can also show it like this, plus, and plus. Okay, so we got the charge, we got the atomic number, which is the number of protons. Now we need the number of neutrons. So number of neutrons is the mass number, which is given to you, minus the atomic number. Okay, and atomic number. So here the mass number is m, and the atomic the mass number is I think Z is the atomic number. So anyway, so here we have the mass number and the atomic number. The difference of that would be the number of neutrons. So the mass number is 195 minus the atomic number, which is the atomic number is 78. So 195 minus 78 is going to give you the number of neutrons, which comes out to be 117. Okay, number of neutrons, and that's the answer. So you have number of neutrons, you got the charge answered, and you got the number of protons answered. Okay, all right, let's look at the next problem. Okay, so here we are looking at problem 2.4, the learning check problem, and this is on page 86. And here we are trying to find the average mass of magnesium atom. Now this is the isotopic mass, okay? So here this problem relates to calculating the average mass of isotopes. So 3 isotopes of magnesium are given: magnesium 24, magnesium 25, and magnesium 26. Now this number that you see, this number is the abundance. So a larger amount of magnesium 24 is found, then is magnesium 25, which is only 10.13% found in nature, and magnesium 26 is found only 11.17% in nature. Okay, so what do we see here? We see in the first case, we need to find like the mass of magnesium 24, which basically a more exact mass of magnesium is 23.98 atomic mass units, okay, times and times, okay. 25 is 24.99 atomic mass units, okay. Then 25.98 atomic mass unit. Now, what does this mean? This means, the first one means 78.70 times 23.98, divide that by 100. Next is 24.99 times 10.13, divide that by 100. And the third one is 25.98 times, I'm just putting it, just give me 1 minute, let me clean it up. Okay, so here we have the first, give me 1 minute. The first one was 78.70 times 23.98. And so when we solve it, this becomes 78.70%. That is the abundant factor. So the abundance factor is the amount that is found in the nature. So we are bringing in the abundance factor times the weight, the mass of magnesium, of that isotope of magnesium. Okay, so 78.70 times 23.98 divided by 100. Or you can also do 0.70 times 23.98. That's also fine. So same way, 10.13 times 24.99 divided by 100. And 11.17, that's the percentage, times 25.98 divided by 100. Okay, so that gives you the mass, the 18.87, 2.53, and 2.98. Now you are going to add these up. You take 18.87 plus 2.53 plus 2.90. And in this case, you get 24.3019 and something, you know. So the book, they have rounded it up and they've given you 24.31 atomic mass units. So this is the number. I mean, obviously there were more numbers here and more numbers here, more numbers here, which I did not, you know, bring in because of the space. But anyway, so this is the number that you will see on the periodic table. So this is the average mass of the isotopes. So when what you see, the mass number written of the atoms in the periodic table, and that mass number is in the decimals. And so this decimals is because technically mass is what? Mass is protons, number of protons plus the number of neutrons. But because we are bringing in the abundance factor also, that is why we see all these, you know, decimals. And this is the number that is written on the periodic table. Okay, so let's look at the next problem now. Okay, so our next problem on page 86 is the learning check 2.5. Okay, so here we see we are given the mass of two isotopes of copper, copper 63 and copper 65. 63 mass is, to be more precise, is 62.9296 atomic mass units, and the mass of 65 is copper 65 is 64.9278 atomic mass units. Okay, now we are being asked to find a percentage composition of copper. So how do we do that? We will have to assume that the percentage composition is X. Okay, and we will solve for X. So we will set up our problem like this. We will have the average mass that is given to us. The average mass is given 63.54. We put it here. And then we take the next one is the copper let's get another color. The next one is copper 65 mass. And then the copper 63 mass. Okay, it doesn't matter because we're solving for X. So let's say X times the mass of copper 63 added to 1 minus X times the mass of copper 65. Okay, so we set up the problem like this, and the rest is just put in the numbers, which is now the average mass given is 63.546. 63.546 atomic mass units, always write the units, is equal to X multiplied by 62.9296 atomic mass units. This is the other one, the first one, and then 1.00 minus X times copper 65 is 64.9278 times 64.9278 atomic mass units, and then this closes, and now you start solving. Okay, so need more space here. 63.546 AMU is equal to 62.9296X, right? That's multiplied, and that's the atomic mass units. So X AMU plus, okay, 1 multiplied by 64.9278 atomic mass units. Okay, minus, and so this is still, let's just keep it in the brackets, and this also, let's keep it in brackets. Okay, minus 64.9278 X atomic mass units. Okay, remember that this is 1 multiplying by this number, and then X also multiplying by this number. So that's how you get these. Next is you will bring all the like terms on one side and the unlike on the other side. So you have now 63.546 atomic mass units, and the plus, so this becomes minus 64.9278 atomic mass units is equal to 62.9296X minus 64.9778X. Okay, let's solve this. Okay, so there was a little discrepancy I made. I realized it when I was calculating. So here, this number 9278, okay, so 64.9278 is subtracted from 62.9296 X, okay, and 63.546 minus 64.9278. So when you subtract that, you get 1.38, but negative signs are canceling out on both the sides. And then here you get 1.99. So just make a note of it. I had a wrong number written here. So in this piece right here. So 64.9278. And then that one, that is subtracted from 62.9296. All right. So anyway, so you get 1.99. And when you cancel this signs out, you get 1.38, and bringing the 1.99 on the other side of the equation, you get the value for X to be equal to 69.34. So remember that X is equal to 69.34. This is percentage of copper, which is copper with a mass of 62.9296. Copper 62 0.9296, which is actually written as copper 63. Okay, but the other one is 1.00 minus the X. So that is equal to 1.00 minus, sorry, this is, oh God, what am I doing here? This is 0.693, actually, not 69.34. That's obviously the percentage. So the value of X comes out to be 0.693. You know, that's the thing. During the daytime, there's a lot of distractions. So I'm sorry if for this. So, but we got to do what we got to do. Okay. So this equalizes to 69.34 actually percentage. Okay. So anyway, so here 1 minus 0.693 and 1.00 minus 0.693, and you get 0.307, and that equals to that X is equal to actually 30.70%, and that is of copper, and that is copper, which is the other one, copper 64.9297. 64.9297, and that is equal to copper 64. Okay, so one of the percentage is 69.34%, and the other one is, this is for the copper 63. Copper 63 is this, and copper 65 actually is 30.70%. Okay, so in that range. All right, let's look at the next problem now. Okay, so now we are looking at the example 2.6, and that is on page 90. Okay, well, actually page 91. All right, so here we are given the problem in which we are asked to write the molecular and the empirical formula. We are given 8 atoms of carbon, 16 of hydrogen, and 4 of oxygen. So what does the molecular formula look like? The molecular formula in this case is C. We write down in the subscript 8, hydrogen is 16, and oxygen is 4. Okay, so we write it in the subscripts, C8, 816, O4, like this. But the empirical formula is actually the lowest whole number ratio, with really simplified version. So molecular formula actually factors in the bonding, okay? The bonding in the atoms, like the capability to make the bond. So that's why you have this. But the simplest whole number ratio is just like how many atoms are just technically combining. So in this case, the lowest whole number ratio, carbon, hydrogen, and oxygens would be basically multiples of 2. So or even, 4. So here you have 1 of oxygen, 4 of hydrogens, and 2 of carbons. So empirical formula does not include the factor in the bonding. No, carbon will make 4 bonds, but we simply look at the simplest whole number ratio. Okay, let's look at the next problem. Okay, so the next problem that is on page 98, and here we are looking at the names of the group numbers. So we are given krypton and selenium and barium and lithium. So first thing is you should know where they are in the periodic table. So krypton is present here. So krypton is Kr, stands for krypton, that's the symbol and the name, and it belongs to the noble gases. Okay, so you should know the name of that column. Next is selenium. So see, where is selenium? Selenium is Se, and selenium is present in the okay, so selenium is here, and the selenium belongs to this group that is called chalcogens. Okay, so that's the name of the group 6A. 6A is more representative, but chalcogens, that group, the entire oxygen, sulfur, selenium, tellurium, and polonium, and livermolium, all these guys chalcogens. Okay, so noble gases was krypton, selenium, chalcogens. The next group there, the next question is barium. So where is barium? You should know, where is barium located in the periodic table. So barium is here. Okay, so you just have to get used to looking at these elements, and we see this is in the group 2A, and that's barium. But what is the name of that group? The name of that group is the alkaline earth metals. Okay, the alkaline earth metals are in group 2A, and let's go back. Okay, so barium alkaline, see if I can't highlight it, but anyway, so that's the alkaline earth metals, the second one, the alkaline earth metals. Okay, so that's the second, now it's highlighted. So the second A. Okay, next is the lithium. Where is lithium? Lithium is here. Okay, and lithium is in this first column, and the lithium is the alkali metals. And these alkali metals, again, these characteristics are there, but let's just focus only on this one. Oh, sorry, this keeps on. Now I can go back. Anyway, so you get an idea. So basically, krypton, write down krypton, noble gas. Selenium, chalcogens. Barium, alkaline earth metals, and lithium, alkali, sorry. Alkali metals. Okay, so let's look at the next one. All right, so the next question is on page 100, and here's the problem 2.8. So they are looking at these symbols and the names of the ion. So what is that ion? So you are given the number of protons and you're given the number of electrons. Remember, it's always the number of protons that determine the identity of atoms. Number of protons that determine the identity of the atoms. So how will you get that? This information, you are going to look at the atomic number in periodic table. So let's look at the periodic table. And in the periodic table, we have to look for that atom that contains 34 protons, or in other words, that one that contains the atomic number is 34. Okay, so you know all these are arranged. The good part of the periodic table that they are arranged in the increasing order of atomic number. Hydrogen is 1, helium is 2, lithium is 3, beryllium is 4, boron is 5, carbon is 6, nitrogen 7, oxygen 8, fluorine 9, neon 10, then sodium 11, magnesium 12, aluminum 13, selenium 14, phosphorus 15, sulfur 16, chlorine 17, and argon 18, and so forth. So you can just go in that order and go to 34, because we're looking at that atom that has 34 protons, or the atomic number is 34, and that is selenium. So that's one identity. Next thing, there are 36 electrons. So let's go back and write down. So we got selenium, and selenium has, so this is 34, right? The 34, the atomic number, but it has got, that is the number of protons, but the number of electrons are, 2 more. So that is 36 is the number of electrons minus 34, that's the number of protons. Okay, and the difference is 2, and there are more protons. Okay, so there are 2 electrons. So 2 more electrons, therefore 2 minus charges. Okay, and so how do we write this now? Selenium minus 2, and this can also be written as selenium 2 minus, or it can also be written as 2 negative charges. All the 3 are correct, but name is called selene IDE, okay, because it's just a selenium just by itself. So it's the IDE, selenium, okay? Let's look at the next problem. Okay, so our next problem is 2.9, in which we are actually looking at the writing the formula and the names of the compounds and so forth. So here, just a little review, and in detail, I have covered the whole thing in another periodic table and the nomenclature video. So please explore that. But for now, let's just look at this. Review the trends in the periodic table. So we know that the group number relates to the number of electrons that are present in the last shell, and that also determines the ability of the atoms to make the bonds and the kind of charges it is going to have. So the whole thing is, the main force is basically to look like the nearest noble gas, or to get the electronic configuration similar to the nearest noble gas, or to get the 8 electrons in the last shell. Unless they are, of course, the d orbitals and like the transition elements and the post-transition elements, there the half-filled and the full-filled orbitals are more stable. So that, rule applies. But anyway, this is a general trend. Group 1A elements, all of them will have +1 charge. Group 2A will have +2. Group 3A +3. Group 4A +4. And it also can have a -4 charge, but it can also form no charges. In other words, it will form covalent compounds. The group 4A can also form that. Okay, covalent bonds are formed by sharing. Next is group 5A will have -3 charge, group 6A -2 charge, group 7A is -1 charge, and group 8A is no charge. Okay, now group 1A, 2A, 3A, these are metals. Group 5A, 6A, 7A, and 8A, these guys are non-metals. And of course, there are the post-transition elements, which are the metals and the metalloids also present, right, in the non-metallic side, which is on the right-hand side of the periodic table. And these are also the the p block elements. Okay, but the groups 1, 2, and 3, basically group 1 and 2 contains majority of metals. So group 3A, we have aluminum, and then we mostly, so let's just look at it here. This would be aluminum with +2 charge, with +3 charge. And then group 4A, like I said, carbon has a capability, but the rest of them will form like all positive charges, with a negative charge is carbon. And then carbon can also form carbocation, carbon can form carboanion, that is in group 4A. But let's look at group 5A. Group 5A will have nitrogen, and then there is also phosphorus. Phosphorus can have -3 charge, but phosphorus can also form, 3-5 bonds also. So that's why. So this is -3 here, and then phosphorus, and then there's arsenic also can form -3. And then comes the oxygen. Oxygen can have -2, sulfur can have -2, selenium -2, and then tellurium also can form -2. Then comes the 7A. 7A, you have fluorine, you have chlorine, you have bromine, and you have iodine. And these guys will have -1, -1, -1, and -1. So that's the main thing. And then the first ones are obviously we have lithium, sodium, potassium, rubidium, cesium, and francium. All of them will have +1 charge. And then the next one, we have beryllium, magnesium, calcium, strontium, barium, and radium. All of them, radium Ra, all of them will have +2 charges. Okay, so these are just the common trends. Okay, and next we know that whenever there are non-metals just by themselves are going to end in "ide." Okay, metals for the most part, just their names do not change, the names remain the same. And for the binary ionic compounds, we do not use the mono, di, tri, tetra with the nomenclature. So just keep that in mind. So it is not going to be magnesium dichloride or aluminum trichloride. That doesn't happen. Okay, next is naming metals with more than one positive charge. So these are basically transition and post-transition elements. So transition and post-transition. Okay, so for your homework and quizzes, you can look into the tables and the tables that are in the handout. If something is missing, you can add more, but if you could memorize them, that will be great. Okay, so what we see here is that iron can form +2 and +3 charge. So how do we name this? Now, +2 is a lower valence state. In other words, lower oxidation state. And +3 is a higher oxidation state. Oxidation means a positive charge, means loss of electrons. That also means commonly, that's the way we say it. So Us applies to a lower oxidation state and Ik applies to the higher oxidation state. So here you have copper also existing in +1 and +2. The lower oxidation state of copper is +1. The higher oxidation state or a higher charge, positive charge, is Ik. Then you have the tin. The tin is +2 and +4. The tin can exist in +2 state. That is a lower oxidation state. That is why it is called stannous. A higher oxidation is stannic. And then you have lead also, same story. +2 and +4, two charges lead can form. Lower oxidation state is plumbous, higher is plumbic, and so forth. There are many others. So we use Roman numerals also to write their names. So instead of using the Us and the Ik terminology to show the lower or the higher states, we can also use the Roman numerals, such as 1 is written like this, I. 2 I's are like, it means 2. 3 I's would be 3, right? The letter I. And then I and a V is I is written first and V, that is 4. A V alone is 5. V and another I is 6, and so forth. Okay, so common Roman numerals are written like that. So copper in a bracket. So another way of writing cuprous would be copper, brackets, I or 1. Cupric, copper, brackets, 2 I's and brackets closed. Stannous is tin, 2 I's. Okay, like that. So that's one way of writing the, 2 ways of writing these elements, the names of the elements which form more than one positive charges. Now, next thing is the, we will look at this crisscrossing. Next is the polyatomic ions. Okay, now polyatomic ions are like many of them are just the oxy anions. In other words, the ones that contain a certain number of oxygens and with respect to every atom. So for example, carbon, the maximum number of oxygens carbon can hold is 3 and with a negative charge. So that name is carbonate. 8 represents a higher oxidation state, or in other words, higher number of oxygen atoms. Now comes the nitrogen. Here is the nitrogen. Nitrogen can contain 2 oxygens and nitrogen contains 3 oxygens. Nitrogen can bond to 2 oxygens and nitrogen can also bond to 3 oxygen. So lower oxidation state is nitrite, ITE. Both of them have a negative charge, but it's how many oxygen atoms are attaching to nitrogen only. So lower is 8 and higher is 8. So nitrate is NO3, 1 negative, and nitrite is NO2, 1 negative. Then comes sulfite, ITE, sulfite. Okay, sulfite and sulfate, ATE. Sulfur can attach to a maximum of 3 oxygens and sulfur can attach to maximum of 4 oxygen. The highest oxidation of sulfur is with 4 oxygen. That is why the name is sulfate. So note this, don't get into this mindset that 8 would only apply to 3 oxygens. No, sulfur, lower oxidation state is with 3 oxygen. So the name is sulfite. But sulfur has a maximum capability to combine with 4 oxygens, and more oxygens can come in sulfur. So the higher oxidation state in sulfur is sulfate, and that is SO4, 4 oxygen. Same story with phosphate. Phosphorus can combine with 3 oxygens, and the maximum, the highest number of oxygen that can attach to phosphorus is 4. Of course, with the charges, okay? So both of them will have the 3 charges, but the lower oxidation state is phosphide, a higher oxidation state is phosphate, okay? Now, we also looked at the chlorine. When initially we discovered that chlorine combines with 3 oxygens and negative charge, 1 negative charge. So we called it chlorate. So chlorine, so this is all of these are with chlorine, with respect to chlorine. So let's put this here. This is with chlorine, all these 4 with chlorine, okay? But initially we discovered that chlorine can combine with 3 oxygens. So we said, okay, give it a name chlorate. And we said, okay, chlorine can combine with 2 oxygen also with the names with the negative charge. So we called it chloride. Okay, it's a polyatomic ion, right? So there's going to be a charge. Next, later on, we discovered that chlorine can bond with 4 oxygens. So now we cannot change it to chlorate, but we said, okay, we're going to change it and make it perchlorate, means higher than chlorate. So maximum number of oxygens that chlorine could bond was 4 with a negative charge. And so that is the perchlorate. And chlorine can also bond with only 1 oxygens. So then we can't change it to chloride, a lower oxidation state. So we say, okay, what is the lower than the lowest? It's the hypo. So hypochlorite is lower than the ClO2 with a negative charge. So it is just 1 oxygen with all of them have the negative charge, but this is how they're named. Besides that, this is something you guys have to memorize now. We also have the ammonium, NH4 plus 1, hydroxide. Now the name hydroxide, although it says hydrogen should come first, oxygen could come next, no, something, you know, some of the names came at different points of time. So hydroxide is OH minus. Then bicarbonate or hydrogen carbonates or hydrogen sulfate or hydrogen phosphate will have hydrogen or right? Bi is coming from there. Bi does not mean 2. Bi just means hydrogen is present, and if it is attached to carbonate, it becomes bicarbonate. If it is attached to sulfate, it becomes bisulfate. If it is attached to phosphate, it's biphosphate. And then, you know, the charges are also different here. So keep that in mind that this is, you know, because hydrogen is like H plus, so it neutralizes 1 negative charge. Okay, now comes the dichromate. Dichromate is 2 chromiums and monochromate is just chromate. Okay, so just keep that in mind that if CrO7, Cr2O7 and CrO3, these are the chromium attached to oxygens. Okay, and then cyanide, you know, Cn minus and so forth. So these polyatomic ions are very important. Then comes the acids. Now the acids are again the if the hydrogen is in front and there is just the you know, aqueous a halogen like fluorine, chlorine, bromine, iodine, then all of them will have hydro, and then the non-metal, and then ic and acid. So hydrofluoric, hydrochloric, hydrobromic, and hydroiodic. Okay, but remember that these are acids. They're going to be in the aqueous medium, that is water. So AQ. Okay, oxonium ions. Now, for example, if you have H2SO3 and you have H2SO4, how do we name them? So we name them depending upon the lower oxidation state of the anion or the higher oxidation state of the anion. So remember, us and ic. Ic is a higher oxidation state or a higher positive charges, you know, in the case of metals, and us is a lower oxidation state or less number of positive charges in the case of metals. So the same rule applies here. So this becomes sulfurous acid and sulfuric acid. Okay, so same thing would be phosphorus and phosphoric acid. So H3PO3 and H3PO4 respectively. Okay, next is the non-metals. Now non-metals are formed by the covalent bonding. Okay, so this is the covalent compounds. Now covalent compounds are formed when there is a sharing of electrons. So in this case, no like bonding, no transfer of electrons occur. So sharing of electrons. So therefore, no charges. Okay, in the case of ionic, there are charges. So how do we name them now to differentiate? Mono means one atom, di means two, three means tri, tetra, four, penta, five, and hexa, six. So for example, carbon attached to one oxygen, carbon monoxide, carbon attached to two oxygens, carbon dioxide. So remember that the carbon, the name of carbon is not changing. It is the same, but its mono is telling you how many oxygens are there. Similarly, if you have a name like this CCl4, this becomes carbon 4, tetra, and chloride, because it's just the chlorine attached just by itself, to carbon then. So same is the case. Now look at this. If there is, because there's only one carbon, so it's carbon monoxide, right? And carbon dioxide. But if you have in the first element is two or more, then this becomes diphosphorus, penta oxide. Okay. So these are the general naming. Now we are going to go back, and then that is just general naming, and I reviewed this. So now let's look back at this problem, which is 2.9, page 101. So page 101. So here, what do you have? You have here aluminum and carbon react to form the ionic compound. So anytime you have ionic, the word ionic compound, that means we're talking about charges. There are charges there. Ionic compound means ionic compounds are formed by the metal reacting with a non-metal. Okay, so the metals will have a positive charge, or metals form cations, and non-metals will have a negative charge and they form anions. Okay, how many charges are formed? Based on the tables we just now reviewed. Okay, so we are talking about aluminum. Aluminum is coming from group 3A. So the charge on aluminum is +3 because aluminum is a metal. Carbon is in group 4A. So here it is a non-metal. So the charge is -4, and this is a non-metal. Okay, so carbon and aluminum react to form an ionic compound. Predict which forms an anion and which forms a cation, the charge on each, and write the symbol of each anion and name them. So here we see, in this case, we would have aluminum +3 and carbon -4. Okay, so let's just move a little forward. So these are the ions, and then when you do the crisscrossing, you see that these 4 and this crisscross. So now we have aluminum 4, and carbon will have 3. Okay, so let's change this to here this way. Okay, so the name becomes aluminum. The name of aluminum doesn't change, it remains the same, but the other guy becomes carbide, IDE. So you will get a feel for it, but because it's just carbon and not a polyatomic ion, so the name comes like that. Okay, let's look at the next problem, which is 2.10. Okay, so the problem is on page 104, 2.9, and they're saying predict the formula of the ionic compound formed between sodium cation, that is Na+, and sulfide anion, S-. So what is formed? So again, this number comes here and this number comes here. Okay, so what do we get? Na2S, and then 1. Remember, the number 1 we do not write, so we do not write for 1 as subscript. So although we brought 1 from the top of sodium here at the base of sulfur, but it is not written. So it is just. Second thing, we do not write the charges. So whether you are bringing a positive charge or a negative charge, okay, charge in subscript. So when you cross over, you do not bring the plus or minus, you only bring the numbers, but all the numbers that are above 1. Okay, so what is the name? Name is sodium. The name of the metals don't change, but sulfur becomes sulfide, S-U-L-F-I-D-E, because sulfur is just by itself. Okay, next, let's look at the next problem. Okay, so the next problem is 2.11, and this is on page 104. Page 104. So here they're saying that a lithium ion is given, and you are given a peroxide ion, and they've given you the formula of the peroxide ion, and they're saying that find the predict the formula of the ionic compound formed when lithium ion reacts with the peroxide ion. So what is the formula of the compound? So here lithium is in group 1A. So the charge on lithium is going to be +1. So therefore write down lithium +1 charge, and here's this O2 -2 charge. And the next thing you will do is crisscross. Bring this number here, but do not write it. So it just kind of like it's there. And then this number comes here. So what do we have now? We have Li2O and then O2, Li2O2. But do not write for number 1. Okay, so the same thing we covered on the previous example. So this is the formula of lithium peroxide. Okay, all right, let's look at the next. All right, so the next question is this is 2.12, and this is on page 105. Page 105. Okay, so you are given the problem here: using the periodic table, predict whether the following compounds are ionic or covalent compounds. Okay, so ionic compounds are, as we said, between the metals and the non-metals. When metals and non-metals combine, then we have the ionic compounds. But covalent compounds are between the non-metals only. Okay, now sulfur is a non-metal, so I'm going to just put N, M, and then metal is just M. So it's just, so this is sulfur is a non-metal, oxygen is a non-metal. Okay, calcium is a metal, fluorine is a non-metal, and you will have to look in the periodic table to determine which is which, what is placed where. Okay, next is you have nitrogen, which is a non-metal. Hydrogen is also a non-metal. Aluminum is a non-metal, and it is combined with the polyatomic ions. Remember, this is an oxyanion, sulfur, and then both the polyatomic ions are non-metals, okay, with a charge. Okay, so that's one thing. Now, whenever the two non-metals are combining, that means this is a covalent molecule. When a metal and a non-metal combine, then we have the ionic compound. When a non-metal and a non-metal combines, then we have the when a non-metal and a non-metal combines, we have covalent. And when we have a non-metal and a polyatomic ions combine, it's always going to be ionic. Okay, so that was 2.12. Now let's look at the next problem, which is on 2.13, and that is writing the formulas of the ionic compounds. So, okay, so now here we are given the formula of the ionic compounds, and we are, the names of the ionic compound, and we're being asked to write the formulas, right? So chromium, so know the symbols, chromium. And if something is given to you in the parenthesis, that means that that's a the particular metal that is going to make more than one positive charges. Okay, so here's this chromium with +3 charge. So just put it like that. Now phosphorus, remember, phosphorus, phosphide, belonging to group 5A, and the charge is -3. So here is your phosphorus bringing -3 charge. Sorry about that. All right, sorry about that. Okay, so here we have the chromium with +3 charge, and we have phosphorus, phosphide, with -3 charge. Okay, so when you crisscross, you bring 3 at the base of phosphorus, and this 3 goes at the base of chromium. But remember that +3 and -3 cancel each other out. So we have chromium with 3, and we have phosphorus with 3. But when they cancel out, the actual formula is CRP. Okay, chromium phosphide. Next is Mercury Two Sulfide. So here we have mercury as Hg, and it is in brackets 2, means +2. Okay, or 2 plus, same thing. Then sulfur. Sulfur is in group 6A. The charge on sulfur is equal to -6. All right, so oh sorry, -2, sorry, -2. So here is your sulfur with -2 charge, and once again, when you crisscross, you bring 2 at the base of sulfur, and this 2 goes at the base of mercury. And what do you have? You have Hg and S, because you cancel out that 2 and 2 cancel out. So this becomes HgS. So although it is Mercury 2 sulfide, because of the charges, they cancel out. All right, next is Manganese 2 Phosphate. So we will write manganese is Mn. 2 means +2 or 2 plus, and write down the formula for phosphate. Phosphate is what it is. So name of the polyatomic ions is, you just write their names as is. So phosphate is PO4 -3. So write down the whole thing. Okay. Next is crisscross. Excuse me. So this 2 goes here, and this 3 comes here. Okay. So now what do we get here? We have now, let's make this a little bit bigger, Mg. Now we have Mn, sorry, manganese, Mn3, because the subscript you are bringing down is more than 1. Okay, so parenthesis, phosphorus goes in the parenthesis, and 2 comes outside the parenthesis. Okay, so when more than 1 plus charge is crossed, then polyatomic ions are put in the brackets. So this is the story with manganese phosphate. Next is copper 1 oxide. Copper 1 oxide means copper +1. Oxide, oxygen, okay, belongs to group 6A, okay, and the charge is -2. So this is something, it comes with practice, or it comes with memory. Oxygen is -2. And now you are, this number comes here, and then this number comes here. And you have now copper 2O, okay? Copper 2O, that's the formula. So I have to write this in a different color. Cu2O. Okay, and then same is the case here. Mn3 brackets PO4 whole twice. Okay, and then see. All right. Next is iron 3 dihydrate. Now here di means two. Hydrate means water molecules. H2O. H2O is, there are two water molecules attached to the iron 3 chloride crystals. So iron is Fe, okay, and 3 means it has +3 charges. Chlorine is Cl. Chlorine is in group 7A, and the charge on chloride -1. Okay, so we will write down here Fe +3, chlorine -1, and we crisscross. This number comes here and this number goes here. So what do you have? You have now Fe Cl3 dot 2 H2O. So you put the water molecules dot. Okay. If you have, let's say, pentahydrate, it would mean dot 5H2O. Okay. So that's the deal with the hydrates and naming them like that. Now comes naming the covalent, and that's the last one. All right. So just hold on to the last one now. Okay, so here we are writing the formulas of the compounds, the covalent compounds. Now, covalent compounds, we are going to use mono, di, tri, tetra. So your first one is the formula of phosphorus pentachloride. So phosphorus penta. Actually, when we write it, it's a small p. Pentachloride, all one word, pentachloride. So phosphorus would mean P, chloride is Cl, but penta, how many chlorines are there? 5. So this is what we write, PCl5. Okay. Next is dinitrogen monoxide. B is this is the, there is a reason they go. So this is dinitrogen monoxide. So in this case, the name is dinitrogen, means 2 nitrogens. Monoxide means just 1 oxygen, like that. Okay. Next is iodine heptafluoride. So next is C, iodine heptafluoride. Iodine heptafluoride. So iodine heptafluoride is, iodine is I, heptafluoride. Hepta means 7 and fluoride is F, and there are 7 fluorines. That's what it means. Okay. Next is carbon tetrachloride. We covered this example earlier. D is carbon tetrachloride. So carbon tetrachloride would be what? C for carbon. There are tetrachloride means that there are 4 chlorines. Okay. All right. So that finishes up the learning check problems from this chapter. All right. And best would be to practice. All right. And thank you for watching. Bye-bye.